My presentation for today is Smart Sensor for Physical Therapy in IoT Era. As was presented, I am working in the University Institute of Lisbon, and also I am a senior researcher of Institute of Telecommunication. It's a national research institute. The outline of my presentation, I try to, okay. The outline of my presentation include elements about facts, technology, and challenge, related physical therapy, IoT technology. It's a brief presentation about IoT technology and how this technology can be related with physical therapy in the way to improve the physical therapy capabilities. And I will speak instrumented working aids, wearable sensing solution, and serious game for physical therapy and conclusion. Few facts related physical therapy. One of the stroke patient recovering in rehabilitation clinic increase every year because of aging phenomenon. 15 million people suffer stroke worldwide each year. And from this number, 5 million need to be recovered after a very long and painful rehabilitation training. Especially the stroke prevalence is for elderly people. However, nowadays, considering the stress in the society, many young people, or let's say medium young people, are suffering this kind of events. Another group of people that motivate us to develop some solution, innovative solution in the field, are the young people that suffer cerebral palsy. There are about 17 million people worldwide, and 2 in 1,000 Europeans suffer this disorder. In this case, it's very difficult to implement physical rehabilitation, taking into account normally the age of these patients. Usually the physical therapy is provided like service in different clinics. However, in these clinics, we still continue with very basic mechanical device that don't give feedback not to the physiotherapist, but also don't give any feedback to the users. That means the motivation of this patient to decrease day by day, and the rehabilitation period increase day by day. Exists also some objective evaluation that can even give an idea to physiotherapists to improve the plans or to have a feedback about the applied plans. Objective evaluation that normally in regular clinics, they are mechanical way. And also exists subjective evaluation of the level of improvement related motor activity. And we speak about here about pain scale, that it's a subjective way and depend a lot to the patient. Some idea is to move in the era of IoT. Nowadays we speak industrial Internet of Things or Industry 4.0. We speak about smart city. We speak about IoT healthcare. And in this case, we speak about also about physical rehabilitation based on Internet of Things architecture. And here the idea is to deploy sensing and communication capabilities on the level of these classical systems that already are working in clinics, but also to develop innovative solutions that can be used by patients during the training in order to extract information about capabilities, motor capabilities, to predict the future developments during the training and to validate the training plans. In this case, IoT can play an important role we can see here that we can deploy sensing on the body of the person, but also on the level of training equipments. And in this case, we can provide information to physiotherapists, but also report, objective reports to the patient. And in this case, increase the motivation in the patient and decrease the rehabilitation period. Thinking about IoT, this is it's a new fashion, but still well-fashioned, because IoT appeared in 90s, for sure not so developed, but nowadays we speak about 1 trillion healthcare devices that are connected to the internet that make the IoT implementation huge. In the field of physical rehabilitation, the deployment are less. The big important deployment of IoT in healthcare focused on cardiology and even in other kind of magnetic resonance and other kind of device. However, in the physical rehabilitation, the IoT is less implemented in regular clinics. Few words about IoT technology imply not only the communication, sensing. We have here different communication protocol, long range, short range communication protocol, and also some classical like barcode and QR code. But also we speak nowadays about the computation platform like edge, fog, and cloud computing that can be used to extract data from different levels, thinking about patients, thinking a group of patients that suffer the same problems during the rehabilitation phase. Thinking about communication, long-range communication, that is very important. I can mention here some very known protocols like LoRa that provide us possibility to deliver information for a long range. However, it's necessary infrastructure to deliver the data till up to 11 kilometers. Or we have also other implementation, especially in China, that we speak narrowband IoT. And we hope that in the next future also, the IoT healthcare will include 5G implementation. Another problem is that different devices involve different multiple protocols, and the communication between devices, that means machine-to-machine communication, are nowadays based on different formats and protocol like HTTP, TCP, IPv6, and so on, JSON format for the data transmission. And nowadays, we speak about MQTT, that actually it's a general used protocol in different IoT architecture. A general architecture for healthcare involved, in this case, is particular for wearable solution, involve a set of sensors distributed on the level of the body, a central node that receives the data using short-range communication protocols like Bluetooth, Zigbee, and deliver the data to the important concentration point that we name base station. From the base station, the data is delivered to the machine learning and enable code structure where the data can process it and later deliver it to be visualize it, analyze it on the level of general practitioners, specialized people, nurse, and even people like accompanying person, that sometimes these kind of people, the patient, are making their plan, then rehabilitation plan, even home. And some accompanying person can receive the data using some smart device like tablet, smartphone or tablet. Moving to our implementations, the first architecture that was considered was an architecture that use the smart walkers and crutch like the equipments, let's say like smart equipment. That means the equipments that was improved with adding some sensors that provide us information about force, kinematic and dynamic condition during the training. Several communication protocols were considered, including Bluetooth, Zigbee, and Wi-Fi that are short-range communication protocol. The data from the smart equipment are delivered to the client side, to the edge side, and for this reason we are using some computer on the first stage, and later we are using some smart device like tablet or smartphone, like a gateway that deliver later the data to the remote server or cloud service, where different architecture was implemented, software architecture was used using MySQL technology, PHP, or in order to visualize the data, some responsive website. Some thinking about the hardware, some of this implementation, one of the prototype was based on Arduino Mega, and we can see here different sensors, including accelerometer, ultrasound ranging system, in order to provide information about the level of the walker during the usage of this, load cells, and all this information is delivered through Bluetooth, or we implement also the possibility to transmit through the Wi-Fi to the server, where the data is stored and later analyzed. Thinking about software implementation, we have here a set of users that was defined, like administration, physiotherapist, and patient. User can perform different actions using the implemented applications. We develop application for mobile device, but also web app application. And according to different rights in the application, the physiotherapist can see the data, create a new training plan, see the patient workout, and we try to do different tests. Some of the tests was carried out in clinics together physiotherapists. In this case, thinking about smart walker, the idea was to see the balance of the user during the usage of this kind of walker. I want to mention here that the usage of walker sometimes is risky when the user don't know exactly to use the walker. We can see the concentration of center of force in some cases when the balance is not so good. When the balance is very good, we can see for different route a distribution of center of pressure that was sampled in with quite high frequency. We speak about till 100 hertz measuring sampling frequency in this case. And we define also together the physiotherapist some metrics that can give us information about the balance and also about the correct usage of the walker. And the two index was defined, one of the imbalance index, and here we consider the center of force, and if the center of force is not inside the surface defined by the legs of the walker, where are mounted load cells, in this case we can estimate the level of balance, but also motoring coordination. That is the rank that define the good or the wrong usage of the walker. And here we implement a finite state machine where we define different states of the usage of the walker. I can mention here, waiting to the walker to lift off, walker is flying, waiting for injured foot to move forward. I want to mention here that actually all the people know that normally the stroke affect one of the parts. That means that the left hand and the left leg, or the right hand or the right leg. That means when I mentioned here injured foot, it's actually the part that was affected during the stroke event. And we develop it also a lab view application to visualize the index during the training. And we can see here a very short movie when we can see the usage with a volunteer and center of force and the calculation of different values of metrics. Another implementation focuses this time to the crutch, smart crutch. After using the walker, normally the patient are moving to the usage of the crutch. If the balance is still not good and he is still affected by some pain on the part that we try to make the improvement of motor capabilities. Here actually was developed a system, include mainly some force and accelerometer. The force was measured with flexible sensors from TechScan FlexiForce that was deployed on the hand support, but also the load cells on the bottom of the crutch to measure the force applied during the usage of the crutch. It's very important to mention that these measurements are considered taking into account that the user sometimes feel afraid to give up using this crutch. That means even if he don't really need the crutch, he continue to keep the crutch for his safety. That is not bad, but we need to know if actually they still need the crutch, or it's a problem of let's say in the mental problem of thinking about his safety. The implementation include also Android technology. That means we develop a mobile application that receives through the Bluetooth the values from the sensors, store and deliver through the Wi-Fi the values on the level of MySQL database. Also was implemented a local database in the way that if no internet connectivity is possible, the data will be stored in the local database and later will be synchronized with the remote database. Here some values, some data that we receive from the force sensors and also from gyroscope that give us information about the position of the crutch during the training. Some movies can be here visualized, related the possibility. We trained some volunteers. Unfortunately, it takes some time to run the movie. Let's see. And actually, during the training, we can visualize the values delivered by inertial measurement unit, or even from the force. And the physiotherapist can take some decision based on objective values and not like before I mentioned, mainly subjective values. Okay. Okay. The next implementation that we think about the usage of the augmented reality and mixed reality for physical rehabilitation. like the implementation of a virtual personal trainer. The technology that was used is based on augmented reality kit from Apple. And we are using actually an Apple smartphone that receive the data from Bluetooth low energy sensors, especially sensors that are measuring the electromyography and the electrocardiogram. The electromyogram is very important in order to extract information of muscle activity during the training, but also the electrocardiogram, and it's used to measure the heart rate in order to avoid some accident during the training. We are actually implement also additional node like sweat analyzer. We know that during the physiotherapy, the people are losing different ions, but also are consume glucose from the cells level. And in this case, we develop also a node that can provide us information about the ions concentration, but also here, like we speak, we make some tests with the glucose sensors that give us some information about the level of glucose in sweat. Important, okay. The idea of augmented reality was also extended for the other kind of architecture. In this case, we are using 3D scan sensors that it's named structure occipital 3D scanner occipital sensor that actually provide us information in 3D. And this sensor was part of architecture that also include a smart carpet that give us the position of the user in and also some other information about the gait, and also some sensor Bluetooth that give us information not only about heart rate through the photoplethysmography, but also about the galvanic skin response, that means skin conductivity, in order to know the level of stress during the implemented rehabilitation exercise based on augmented reality. And here we can see some implementation. We speak about the implementation of the maze game. The game was developed in order to develop the balance and to evaluate the balance during different tests of the user. And also we implement the idea is to develop games that can help the people to motivate them to make the exercise and the training plan. The technology that was used in this case was Unity 3D, that is a very good programming platform for the 3D serious game, and also C# scripts. The data was obtained in different way. We have here the path that was imposed during the maze game, and we can extract not only information about the trajectory, but also about the values of velocities during the training. We have also another implementation. This time we speak about virtual reality. The interaction was done using a smart glove set. We have here many technology that was used. Sensing, smart sensing was based on Arduino or Arduino Nano, but the smart gloves include a set of sensors. This sensor provide information through the Bluetooth to to the client side. The client side of the system, it's actually also represented by the virtual game, where in this case, the rehabilitation is focusing on hand rehabilitation. And we can see here some the device that was used. Every gloves include also the flexible FlexiForce, the extension sensing, and also the EMU, that means 3D accelerometer, 3D gyroscope, and also 3D magnetometer. That all this information is fused using some fusion algorithm like Kalman, and in order to extract the information about the hand position. This information are used in order to act in the virtual reality. And two kind of games was developed: games counts down game, and coffee pong game. The technology that was used, Visual Studio, C# and Unity. Some results can be visualized using the implemented mobile application. We are using here the Xamarin platform, and we can see that the user can identify using QR code that was generated when the user makes registration. And also at the end of the game can be visualized different quantities, different metrics like right hand Euler angles, or right hand finger pressure, or even right hand finger extension. That is very important. Another idea was to interact in remote mode with virtual reality. And here I'm presenting an implementation also for hand recovery exercise. The idea was to use the lip motion sensor. The lip motion sensor provide information about the different joints coordinate in 3D. That means we have X, Y, Z for each joint of the finger. And this information is very important also for the physiotherapist when, in the case of stroke or cerebral palsy, he focused on hand rehabilitation. The architecture, the general architecture, as you see, you have the sensing, you have the client side, but at the other side, the data go to the remote server. Remote server delivers the data to the tablet, and the user receives this information. And the user, that means the physiotherapist, can improve the training plan. Here are some few words about the lip motion controller. It use two camera and use 3D stereoscopic image in order to extract 3D information. The information imply different position of the fingers, but also the sensor provide us information about velocity. That also it's an important metrics. That important metric that give us information about capability of the user. Some serious game was developed. Here, one of the basic one. You can the user can use one or the other hand. During the game, all the information about joints of the fingers is stored in the database and later can be visualized. Another idea, thinking about that, sometimes people are necessary not only motor recovery, but also cognitive recovery. And also when we speak about cerebral palsy is very important too, was developed a game based on 10 objects. And here I will try again. I don't know, I'm a little bit afraid to put the video. Maybe we'll block again, but let's try. Okay, seems it worked. We can see the game implementation that we can move different objects, or even we can select specific object. The game, after this, we have the trajectory of different joints, and we can make an evaluation of different joints during the game. Here we have some results, including Poincaré plot that you can compare different points for different users, or you can compare the evolution during the game for the same user but on different times. That means you can extract information about evolution in time of the capability to move his hand. And in order to visualize the data, Xamarin application was developed for smart device like tablet or smartphone. We can see here also information about the position, but also thinking about the game, also the values, the score obtained for during different sessions. And in conclusion, we can say that smart physiotherapy expressed by tailored environments, like we mentioned. In some cases, we speak about augmented reality, mixed reality or virtual reality, and smart object. We speak here about different kind of, let's say, smart gloves, smart walker, and so on, can be very important to extract objective information and to reduce the rehabilitation time. It's very important, the personalization of the serious game. And it's very important also that IoT give us opportunity to deliver data, to store the data, to apply data analytics, to develop in the future some machine learning models that can give us information about the possibility to improve the training plan and to optimize the training plan, giving to the patient more hope to recover quick. Thank you very much.